Hi, I'm Brian Malloy with Apogee. At Apogee, we love APIs. We feel there is a right way and a wrong way to do APIs, and I'd like to share with you some of our opinions about API design. I'll start with the typical poorly designed API and iterate it into a well-behaved RESTful API. The creativity of an application developer to assemble APIs into a meaningful, valuable app can transform a business. If you have an API or are thinking about creating an API, we suggest you think of application developers as very important customers and treat them well. For application developers to adopt an API, it must have some inherent value. It must also be easy to learn. And to make an API easy to learn, you have to do some simple things like great documentation and code samples and test consoles and so on. But the best way to make an API easy to learn is to design it well. Of course, the API has to scale and be high performance, and companies like Apogee can help you do that. But good APIs are really about good design. Idempotent methods, that's a piece of jargon from the world of APIs. I won't be saying things like that in this presentation. Instead, I like to share with you opinions and bias about what represents good API design. Some of these things that I'll say you might agree with, some you might disagree with. I would love to hear back from you. We're still sort of in the early days of APIs, and it would be great to start debating sort of what are the best practices. To do this, let's take a look at puppies. We'd like to model a dog or dogs as if they were an API so that an application developer could come along and create a really great app for puppy dogs. Let's do it the wrong way first. Let's just assume that we've got a bunch of methods that we want to allow the developer to use, and that this list of methods will sort of grow organically as required by our different application developers. So if you look at some of the methods here, we have methods like get all dogs, location verify, food needed, health check, get the red dogs, get sitting dogs. You'll notice that some of these methods have verbs, some of them don't have verbs. If they have verbs, sometimes they're in the front, sometimes they're in the back. An API like this is very difficult for an application developer to learn. A better way to say that is this API doesn't teach the developer anything. It's just an exercise in memorization. And app developers don't generally want to fill their brains with stuff like this. They'd rather go off and learn some new interesting technology or solve some hard problem. So this is bad news for us as an API provider. And it's going to get worse because as our team changes and we bring in new developers, they'll be adding methods to this list. And because there is no self-similarity or obvious structure to this API, the developer, even with the best intentions, is probably going to make this problem worse as he adds new stuff to it. Here's an example of an API just like the one we looked at, but this is a real-world API that handles huge volumes of financial processing. It has the same problems that we saw in our API. Sometimes there are verbs in these methods, sometimes there aren't. Sometimes the verbs are in front, sometimes they're in back. There isn't a whole heck of a lot of logical consistency about why some things are here and some things are missing. So this is a real-world example of some bad API news. Back to our puppies. A puppy's world is big. Beyond just the puppy itself, it's surrounded by things like dog food, squirrels, veterinarians, owners, leashes. So for us to properly serve our application developer, our API is going to have to expand beyond just the dog object to include things like leash, veterinarian, food, and so on. To handle that, in our current design approach, we'll be taking our existing object and multiplying it by all of the n objects that we'll be introducing. This quickly becomes an n by n problem where we end up with a very large and growing API, and as we want to make it more powerful, we're inherently going to be making it more complex. So at this point, our bad API design has us on a slippery slope to not being very friendly at all to the application developer. So we need to sort of check ourselves and go back to a well-known design philosophy, which is keep the simple things simple. A colleague of mine, Scott Regan at Apogee, often says a good API is so easy to use that if an application developer fell asleep on his keyboard, just the forehead hitting the spacebar should still have good things happen. REST is our way to do that. With a well-designed API, you only need two base URLs per resource. The first URL is for a collection, in our case, /dogs, and the second URL is for a specific element. say /dog/bow. What allows us to do this is HTTP already provides us all the verbs that we need: post, get, put, and delete. Personally, I think of these in terms of CRUD: create, read, update, delete, where CRUD maps to post, read maps to get, update maps to put, and delete maps to delete. If you take these verbs and multiply them by our two base URLs, you end up with a grid that looks something like this. Now, this is really interesting because this is something that's actually going to teach a developer about our API, so that when we launch a next resource like a dog park or a dog owner, all the things that the app developer learned on this matrix will be equally applicable to the new matrix. So if a developer wants to do something like get a list of all the resources, like give me a list of all the dogs, he's just doing a get or a read on the dogs URL, and a list of dogs is returned. Excuse me. I like to point out that when it comes to labeling your resources, they're clearly nouns, but in my opinion, they should also be plural nouns. Sometimes I see APIs where there's a mixture of singular nouns and plural nouns. Sometimes they're all singular, sometimes they're all plural. It just makes more sense to have the dogs be plural, because if I do a get on dogs, it's returning to me a list of dogs. If I do a get on a specific dog, I can see that Bo is one of the dogs, and when I ask for the specific dog, I get one back. So the whole plural thing just seems to make sense in this world. Now, this grid was drawn from an article on Wikipedia, which I highly recommend you check out. If you just search for REST Wikipedia, you'll find it. I don't completely agree with everything on this list, and I'm going to highlight the things that I think are a little strange and talk about the things that I think are okay. So if I want to create a new dog, I do a post to dogs. I want to get a list of dogs, I do a get on dogs. I want to delete all the dogs, I do a delete on dogs. If I want to get a specific dog, I do a get on Bo. If I want to update something about Bo, like maybe he was standing, now he's sitting, I'll do a put on dog/Bo. And if I want to delete Bo, I do a delete on Bo. Now, as for these other elements, I would rather see they behave like this. If I want to change all of the dogs from sitting to running, I would do a put on the dog collection with the state changing from sitting to running. If I do a put on a dog, a specific dog that doesn't exist, I think that should error out and keep it very deterministic. Same thing with a post. If I do a post on a specific dog, that doesn't make a lot of sense in my world. Instead, it should be an error. So this is how I recommend supporting a RESTful API. So what we just learned there is verbs are bad, they shouldn't be in your base URL. Nouns are good, and those nouns should ideally be as plurals. That, in a nutshell, is how to build an interesting REST URL. Now, there's some other interesting things that I'd like to talk about. Let's start with associations. How do we associate the case where I want to create a dog for a specific dog owner? Well, in this case, we just chain our resources together. So here we would say if we wanted to get all of the dogs owned by the first family, the Obamas, we would say owners/Obama/dogs. Likewise, if the Obamas got a new dog, we would do a post to owners/Obamas/dogs, and that would create a new dog for us in that collection. Now, what about complex variations? Oftentimes we hear people say, well, my API is unique and it's much more complex than that. And that oftentimes is true. But as a design philosophy, we recommend folks sweep that complexity away to keep the base URL simple. And the HTTP gives us a way to do that with the question mark. So we can sweep all these interesting variations behind the question mark. So if I wanted to get all the dogs that were running in the park that are red, I could string together params like you see here behind the question mark. Again, the goal for doing that is to keep the base URL simple, but still make the complex possible. What about pagination? There are many different ways that the leading API developers do pagination. I highlight here 3 of them: Facebook, Twitter, and LinkedIn. You can read, if you like, what each of these variations are all about. My preference for doing pagination is to do limit and offset. It's used in MySQL, it's used in Postgres, and it's a very simple way to get developers to paginate a subset of the request of collection that they've gotten back. Versioning is a very important problem to solve. Here are 3 examples how versioning is handled by Twilio, Salesforce, and Facebook. In my opinion, the least interesting of these, the one that causes the most harm, is actually Facebook's approach. If you do a search on Facebook API version, your first hits will be discussion boards where app developers, their app stops working all of a sudden, and it's because Facebook upgraded the current API to a new version, and it broke the existing version, and because it was an optional parameter, the developers didn't have that version in their code, and therefore their code breaks. Whereas Twilio and Salesforce, they both have the version in the base URL, so it's not optional. The developer has to specify which version he wants his app to use. I think that's a very, very important distinction. Now, Twilio uses this date format, which I think is actually confusing because I'm not sure if I'm applying date query params to the accounts or what that thing is until I look it up. Then I realize they've actually done this really cool, sophisticated thing for doing versioning with dates that is interesting, but it's not simple. So even though it can handle complex things, it doesn't keep the simple things simple. And Salesforce, they do a nice job, but I have two exceptions with this. The first thing that I like is they put a V in front of it, so that makes it really obvious. But it's kind of buried in the middle of the URL. I would much prefer to see the URL or the version all the way to the left, even if there's some other structure of APIs above it. Putting the version all the way to the left makes it clear that this is a really, really important element of this API. The second thing that I'm not a fan of is they actually put 20.0. As soon as you put that dot in there, it implies both in the minds of the API team and the application developer that this thing is going to rev a lot. When in actuality, a good API should rev very slowly, the interface, and you can do refactoring stuff on the inside, but that interface should be very, very slowly changing. So our preference is that a version communicate with just the plain digit without any decimal points after it. So sum this all together. The version should have a V in it. It should be as far to the left as possible, and the number should just be a simple integer and not some kind of floating point thing with a dot in it. That's versioning. Now, even with pagination, you could have a record of dog information that has too much stuff in it. Like you might just want to know the dog's name, but you have to deal with like years and years of veterinarian records. So how do you limit that to give you back just what you need? Here's how LinkedIn, Facebook, and Google approach it. Um, Google was, I think, the first API provider to do this, where they provide fields as optional query params. Facebook takes the same approach, and LinkedIn does this really interesting thing with this colon notation in parentheses, which if you check out, it actually has a lot of power to it. It's a very compelling thing to do for an advanced developer. If I have, when I look at choosing this from an application developer's perspective, I like Google's approach the best. They have this fields thing. It's really obvious what this is, which is not the case in LinkedIn. And it keeps the simple thing simple. Like if I just want the title field, I just specify that. But they also have the ability to do more complex groupings and subgroupings of the responses that you want back. So in the end, my opinion is you put the fields as a query param. It's really obvious what it is, and you do it. You do a nice simple comma separated delimiter. What about formats? JSON or XML, plist, whatever format you want to send back to the developer in the response. The developer should be able to specify that. Here's three approaches: Google Data, Foursquare, and Dig. Of these, I like Foursquare's approach the best, and here's why. Uh, we're all used to reading file extensions for decades now that say the name of the file and then dot the type of the file. Foursquare takes advantage of that. It's really simple and intuitive to know what that means. Plus, excuse me, it also happens to be the fewest number of characters, unlike Google Data, which has a bunch more characters to get that expressed. That's a minor nuance, but I think it's interesting. Dig takes the worst approach. They let you specify the format, as far as I can tell, in two different styles, both in the header and in the query param. So if these conflicted, I'm not sure which one would win. And for people that just do the content type in the header, although that might be proper academic style REST requests, it doesn't feel very pragmatic to me, because if something is in the header, for most developers, out of sight is out of mind. They're not even going to know that what the header is all about. So our preference here is that you use .json as the way to specify what you want. So for our two URLs, the collection URL and the element URL, it would look like this. Now, what about the rest of the URL? We've been focused on kind of the functional part of the URL, but what about the top-level domain and the subdomains? So here's Facebook, Foursquare, and Twitter. Facebook and Twitter both have multiple APIs right now, which I think is very confusing. I think it might be good for them because I know they can do DNS lookups and things like that to route to different servers, but I think it's kind of crappy for the application developer. So if you're thinking of the application developer as your most important customer, I think you would find a better way to do this and still have one consistent API URL to get developers started. Along with the API itself, all of these API providers also offer sort of a developer portal. Facebook has it at developers, so does Foursquare. Twitter has it at dev.twitter.com. I think developers are used to these short kind of abbreviated things, so I actually prefer dev. So if you roll this all together, here's our suggestion for your top level domain. So if our domain were teachdogrest.com, our API gateway would be at api.teachdog teachdogrest.com, and as we add a new capability, we would keep everything there. The developer connection, the developer portal stuff where you come for your documentation and so on, would be at dev.teachdog2rest. I like that it's short. Developers are used to this way of thinking, and there's a nice symmetry. Both of these are 3 characters. To make it really nice, to put the kind of the frosting on the cake, if a developer types in api.teachdogrest.com, we ought to redirect them to the dev with a web redirect. And then same thing with these other variations. The common variations of developers and developer, they ought to redirect to dev as well to help the developer get there. That, in a nutshell, is what this is all about. Be RESTful. You only need 2 URLs. If you have more than that, you're probably on the wrong track. Don't put verbs. HTTP already has that taken care of. Just look at the great REST documentation that's out there. Use nouns. I prefer to see them as plurals. Sweep all the complexity behind the question mark. And importantly, look at what the leading API providers are doing. They all don't agree with each other, but you can learn some really interesting lessons about what they are doing. Thank you. I'm Brian Malloy. You can hit me on Twitter at landlessness or on email brian@apogee.com. Love to hear your reactions to this and any things that you agree with or disagree with. Thank you. Bye.